Hello everybody and welcome to Severe Weather MN. Today we're going to be showing you a little bit about GR2Analyst, which is one of the nicest weather programs that we know of. We're going to assume you guys know how to install computer programs already, so we're going to skip over that part, but if you need that information, we'll post information in the description on it, and you can also post a comment and we'll be glad to help you out. So when you first run the program, it's going to ask you for a level 2 data feed. The first on the list is the Iowa State L2 feed, which is free and convenient, so just make sure you click OK and just go past that. If something goes wrong and you don't have the feed in there, you just go to configure polling, and this link needs to be in there. So we'll post the link in the description as well. So you can just click add and type or paste it in or whatever, and then there you go. Click OK. All right. So as our name implies, we are located in Minnesota, and I guess the default area is in the southern part of the U.S. We're going to need to get to somewhere a bit closer to home, so we're going to go to Site and Select, and now you get a whole list of the different NWS radar sites around the United States. ADLH, MN Duluth, there we go. Click OK. And here we are, home sweet home. So now what you're going to do is you're going to go up to here and click Start Polling, and it will connect to the server and download the radar data. And here we go. So currently it's early December, and we have a weather system moving through, but since this is all snow with low-level clouds, we're not really going to see anything too interesting on here. So to demonstrate the capabilities of this program, I went ahead and downloaded some historical level 2 data files from June 19th of this year, 2016, when a bunch of tornadoes touched down in northern Minnesota. So I've got those files on another monitor here. I'm just going to drag them in and load them. We'll do another video on how to download historical data in a while, I guess, later this month, perhaps. It's definitely a neat skill to have. So these will just load here, and in the moment we should see some supercells popping up. Okay, here we go. So let's take a look at some of the products we have here. The most common is base reflectivity, and you'll see this if you go on any online radar. It just shows how heavy the precipitation is. So grayish purple would be really light rain, and pink would be really heavy rain. Pretty simple. Base velocity and storm relative velocity both show movement. So red is anything moving away from the radar, and green is anything moving towards the radar. Storm relative velocity has unimportant movement shaded out, and so higher contrasting stuff is what you're going to want to look for. Both these tools are handy for detecting rotation, because when you have a rotating mass, you have two areas of air moving in opposite directions, so this helps to detect that. Anyway, those two are helpful in that case. Spectrum width is also helpful in detecting rotation or inflow, because it kind of measures wind shear, so in each pixel, if there's a lot going on, there'll be brighter colors showing up. So, if there's really turbulent wind patterns or whatever, they'll be visible as yellow. This is about where the mesocyclone was, so there's definitely inflow here. Echo tops, or ET, they show how high the precipitation core in the storm is. This one gets up to about 60 kilofeet, which is a very tall storm, and the taller the precipitation core is, the more likely severe weather is. So vertically integrated liquid shows the density of well, it kind of singles out really dense precipitation areas and how dense they are, so this could be helpful in detecting hail. Vertically integrated liquid does something similar, except it's finely tuned to look for hail specifically, so readings with vertically integrated liquid density tend to be a bit more accurate. Probability of severe hail, I guess as the name implies, it's the probability of severe hail falling. So white would be 100%, and you got 3-inch hail here, so it's pretty big. Maximum expected hail size shows you how big the hail is supposed to be. This, I guess as the name implies, it's the probability of severe hail falling. So white would be 100%, and you got 3-inch hail here, so it's pretty big. Maximum expected hail size shows you how big the hail is supposed to be. This is nice, these two, because you can tell whether or not a storm is producing hail even before the National Weather Service warns it, because they have similar software. Finally, normalized rotation, or NROT. This shows you rotation. Higher contrasting areas would be areas of higher interest, similar to base velocity and storm relative velocity, but it isolates the most interesting areas and displays them only. So some of these other ones we're not going to go over to save time, but we'll post information to sites on those in the description. So, okay, tilt shows you different levels of the storm that you're looking at. 0.5 would be the cloud's base, and you can go further up through the cloud if you want to see different features towards the middle of it. It shows you different levels of the storm that you're looking at. 0.5 would be the cloud's base, and you can go further up through the cloud if you want to see different features towards the middle of it. You're probably looking at the very top of the storm here. Basic functionality here, you click play and everything loops, and you can change the speed by going to view and animation settings, turning it down to slow or whatever it is you want. Set it back to normal here. Okay, so GR2Analyst has some very neat features here. Volumetric mode and cross-section mode are very helpful in distinguishing severe weather. So we'll take a look at cross-section mode first, and you can basically dissect any storm you want, and you can have a full, you can literally see it busted in half like this, and that's really nice. So smoothing, I should go over this real quick. Nice because it's easier to look at, but you need to know that when you have smoothing on, you're not getting as much data, because each of the information in each of these pixels is specific to that pixel, and so when you smooth it, everything gets kind of warped and distorted a little bit, so you might end up missing some things. So it's definitely a good thing to keep in mind. I kind of use them together because having smoothing on is less of an eyesore, but I'll just reopen this really quick. Position and swing, they kind of just help you move around, which is nice because you can see different areas that way. And okay, the most interesting feature I think that this program has is volumetric mode. So you can go here and generate a complete 3D model of any given storm. Very, very handy feature because it allows you to see all kinds of interesting structures you wouldn't normally be able to on two-dimensional radar. You can easily see updraft columns here, overshooting top, everything. You can also change the lighting effects here. If you go to volume light settings, you can change what you're seeing from diffuse to ambient. So diffuse brings it down to darker, ambient brings it down to lighter. Depending on what you're looking at, you might need to adjust accordingly. Azimuth and tilt help you look at different areas. So tilt highlights the top or the bottom. Azimuth side to side. This would be more visible down here. There we go. So you want to look at the underside of an anvil, you could go this way. Oh, yeah, here we go. That would light those features up. Yeah, space and world space are kind of just presets for that sort of thing. Alright, so now what you can do is you can also discern, the different densities of precipitation cores that you want to look at. So if you move this line over to light purple and then over to green, for example, then you get like a cloud outline, and then you can see the areas of heavier precipitation within. Move it over to yellow, or yeah, let's do yellow. Like this, for example, would help you to see updrafts a bit easier. And then, say you wanted a little bit of cloud around everything. There you go. So yeah, that's a nice tool for examining different features in a storm structure. This is definitely a supercell. You can tell by its shape. If you know anything about supercells. We might do a video at some point explaining the different types of thunderstorms and how they work. Okay, so that is the Volume Explorer. I'll just set this back to normal here. So now you can talk about storm tracks. So you can set storm motion vector. To do this, you're going to need to click on here. The mesocyclone is right in this area, so we're going to do place marker here. And we can go to, yeah, I forgot, we got to move a couple slides up, and then storm motion from marker. Now go to set storm motion vector, hit apply. Okay, and I believe it was storm track. Here we go. So now you're basically seeing the direction of a storm's movement. If you loop it, that's about accurate. So it's kind of nice when you're trying to figure out what direction something is moving. These icons here just show you, the information that you're getting. Hail icons, MDA icons, and OSR icons. So the warning boxes are nice because you can click on them and instantly get the text feed from the National Weather Service. So this means you don't have to click back and forth between a radar and your browser if you're trying to figure out whether or not a warning's just been issued. I've had instances where I've had to do that. So that's nice to have that built in. Is there anything I missed? I'm not sure. Oh yeah, panel customization. This is one more nice little thing to have. Just get rid of that storm track here. Okay, panels, you can have up to 4, and you can set each one as something different. So that's nice, and then you can also set a marker here so you can tell what area you're looking at. Yeah, and then you can save your presets, save current panel as, favorite, whatever. So also important for detecting rotation are the mesocyclone detection algorithms. So these will give you these little icons here. Green is weak rotation, and pink is very high. So when you get circles like this, it means the mesocyclone is above a certain level. I can't remember how many kilofeet it was, but it's more towards the center of the cloud. And when you get a triangle, that means a mesocyclone's at the cloud base, and there could easily be a tornado there. There ended up being an EF1 in this area that crossed Highway 2, so that's a prime example right there. Mesocyclone detection algorithms. So these will give you these little icons here. Green is weak rotation, and pink is very high. So when you get circles like this, it means the mesocyclone is above a certain level. I can't remember how many kilofeet it was, but it's more towards the center of the cloud. And when you get a triangle, that means a mesocyclone's at the cloud base, and there could easily be a tornado there. There ended up being an EF1 in this area that crossed Highway 2, so that's a prime example right there. Anyways, I think I've covered just about everything, so if you have any questions or comments, be sure to comment, and we'll be able to help you out if you're running into any trouble. Once again, we'll have information posted in the description, and we're also on Facebook, so hand us a like. Thanks.